Alpha 2. We are on a series of discussion on electric vehicles. So on the second episode, let's discuss on how the electric vehicle functions. In this episode, we'll discuss on the types of electric vehicle design, the batteries, the art of charging, the motor design, and various aspects involved in the working of electric vehicle. How does electric vehicles work? EVs have an electric motor in place of ICE, internal combustion engine. The vehicles uses large traction battery pack to the electric motor and must be plugged into a wall outlet or charging equipment called EVSE, means electric vehicle supply equipment. As it runs on electricity, the vehicle emits only emissions at energy generation source, or it means it's a zero tailpipe emission. EVs are like an automatic car. They have a forward and reverse mode. When you place the vehicle in gear and press on the accelerator pedal, the following things happen. Step number one, power is converted from DC battery to AC for electric motor. Second step, accelerator pedal sends a signal to the controller which adjusts the vehicle's speed by changing the frequency of the AC power from the inverter to the motor. The motor connects and turns the vehicle through a cog. When the brakes are pressed or applied, the car is decelerating. The motor becomes an alternator and produces power, which is sent back to the battery for charging. This is the illustration of the key components, which includes electric traction motor, power electronics controller, DC converter, thermal system or the cooling management system, traction battery pack, charge port, transmission, onboard charger, the auxiliary battery which is needed for running the other auxiliary items.
Electric vehicles, also known as EVs, do not require IC engines to operate. It is powered by an electric motor instead of a gas-powered engine. The electric motor gets energy from a controller which regulates the amount of power based on the driver's use of an accelerator pedal. The electric car uses energy stored in its rechargeable batteries, which are recharged by common household electricity. EVs move along our roadways without burning up fuel or producing harmful exhaust emissions, while generating less noise pollution. Electric vehicles are like an automatic car. They have a forward and reverse mode. When you place the vehicle in gear and press on the accelerator pedal, these things happen. Power is converted from the DC battery to AC for the electric motor. The accelerator pedal sends a signal to the controller, which adjusts the vehicle's speed by changing the frequency of the AC power from the inverter to the motor. The motor connects and turns the wheels through a cog. When the brakes are pressed or the car is decelerating, the motor becomes an alternator and produces power which is sent back to the battery. If you want to understand how an electric vehicle works, you need to be familiar with the physical elements of electric motor. And it starts with understanding the principles of its two major parts, the stator and the rotor. An electric car motor works using a physical process. This consists of using a current to create a magnetic field at the fixed part of the machine, called as the stator, whose displacement sets a rotating part, called as the rotor. The difference between the two is easy to remember. The stator is static, while the rotor rotates. In a motor, the stator uses energy to create a magnetic field that then turns the rotor. What's the difference between an engine and a motor? A motor refers to a machine that convert energy into mechanical energy, while an engine does the same thing, but specifically using thermal energy. When talking about converting thermal energy into mechanical energy, it means combustion, not electric. In other words, an engine is a type of motor. But a motor is not necessarily an engine. With electric vehicles, because the mechanical energy is created from electricity, we use the word motor to describe the device that makes the electric vehicle move.
Now let's run through the key components of an electric vehicle, which includes battery, onboard charger, DC converter, transmission, power electronics, and so forth. Let's see in detail. The battery in an electric vehicle, there is an auxiliary battery which provides electricity to power vehicle accessories. Onboard charger takes the incoming AC electricity supplied via the charge port and converts it into DC power for charging the traction battery. It also communicates with the charging equipment and monitors battery characteristics such as voltage, current, temperature, and stage of charge while charging the pack. The transmission transfers mechanical power from the electric traction motor to drive the wheels. Charge port allows the vehicle to connect to an external power supply in order to charge the traction battery pack. Traction battery pack stores electricity and to be used by the electric traction motor. The thermal system or the cooling management system, it maintains a proper operating temperature range of the engine, electric motor, power electronics, and the components. As we know, when any energy conversion happens or any work happens, there is a heat dissipation. It's an exothermic activity. So the effective cooling or the taking away of the heat is very important to maintain the safety, the efficiency, and the effectiveness of the system. And thermal runaway, thermal management is a very key critical parameter in EV design. Next comes the DC converter. This device converts high voltage DC power from the traction battery pack to the low voltage DC power needed to run vehicle accessories and recharge the auxiliary battery. Power electronics controller. The unit manages the flow of electrical energy that is delivered by the traction battery, controlling the speed of the electric traction motor and the torque it produces. Electric traction motor. Using power from the traction battery pack, this motor drives the vehicle's wheels. Some vehicles use motor generators that perform both drive and regeneration functions.
And even if you've never driven an electric car, it's still relatively simple to wrap your head around its main parts. For example, instead of a gas tank, they have batteries. Instead of an engine, they have an electric motor. And instead of a tailpipe, well, they've got no tailpipe. Simple, right? But there are few other parts that an EV owner should understand. Traction battery pack, power inverter, electric traction motor, power electronics controller, battery, charge port, DC-DC converter, charger, and transmission.
When we categorize the electric vehicle based on its powertrain, it can be plug-in EV, pure electric vehicle, the plug-in hybrid, and hybrid electric vehicle or hybrid vehicle. Let's see what are the differences. Now understand the types of electric vehicle. That is purely based on the powertrain. A plug-in electric that means the car runs purely on electricity and gets all its power when it's plugged into charge. This type doesn't need petrol, diesel or any fuel, fossil fuels or biofuel to run. So it doesn't produce any tailpipe emission like the conventional or the fossil fuel cars, the ICE cars. Next category is the plug-in hybrid. These cars mainly run on electricity but also have a traditional fuel engine. So you can use petrol or diesel also if they run out of charge. When running on fuel, these cars will produce emissions, but when they are running on electricity, they won't. Plug-in hybrids can be plugged into an electricity source to recharge their battery. The third category is the hybrid electric. These run mainly on fuel like petrol or diesel, but also have an electric battery, which is charged or recharged through regenerative braking. I hope you know a regenerative braking mechanism. When the vehicle is decelerated or when the brake is applied, the energy is used for charging back the battery pack. This switch between using the fuel engine and using an EV mode at the touch of a button. These cars cannot be plugged into an electricity source for charging. Rather, it rely on the petrol or diesel for energy.
There are 4 types of electric cars are available. They are battery electric vehicle, hybrid electric vehicle, plug-in hybrid electric vehicle, and fuel cell electric vehicle. Let's find out more about these types in details, starting with battery electric vehicle. It is also called an all-electric vehicle, which ran entirely on battery and electric drivetrain. Electricity is stored in a large battery pack that is charged by plugging into the electricity grid. The battery pack, in turn, provides power to one or more electric motors to run the electric car. Examples of battery electric vehicles are Volkswagen e-Golf, Tesla Model 3, BMW i3, Chevy Bolt, Nissan Leaf, and more. Hybrid electric vehicle. These types of cars are often called standard hybrid or parallel hybrid vehicles. This type of car has both an internal combustion engine and an electric motor. In this, the internal combustion engine gets energy from the fuel, gasoline and other types of fuel, while the motor gets power from the battery. The gasoline engine and electric motor together drive the transmission, which drives the wheels. The difference between hybrid vehicles compared to battery electric vehicles is that in a hybrid the battery can only be charged by the IC engine, the speed of the wheels, or a combination of both. There is no charging port, so the battery cannot be recharged from outside of the system. Examples of hybrid vehicles are Honda Civic Hybrid, Toyota Prius Hybrid, and Toyota Camry Hybrid. Plug-in hybrid electric vehicle. It is a type of hybrid vehicle with both an IC engine and a motor. These types of electric cars provide a fuel option. These cars are powered by a conventional fuel, such as gasoline, or an alternative fuel, such as biodiesel, and a rechargeable battery pack. The battery can be charged electrically by plugging into an electrical outlet or electric vehicle charging station. Plug-in hybrid vehicles typically can run in at least 2 modes. All-electric mode, in which the motor and battery provide all the car's energy. Hybrid mode, in which both electricity and gasoline are employed. Some plug-in vehicles can travel more than 70 miles on electricity alone. Examples of plug-in electric vehicles are Porsche Cayenne SE Hybrid, Audi A3 e-tron, Ford C-Max Energy, and Mercedes C350e. Fuel cell electric vehicle is also known as zero-emission vehicle, are types of electric cars that employ fuel cell technology to generate the electricity required to run the vehicle. In this type of vehicles, the chemical energy of the fuel is converted directly into electric energy. Examples of fuel cell electric vehicles are Toyota Mirai, Hyundai Tucson, River Simple Raza, and Honda Clarity Fuel Cell. You can charge an electric vehicle by plugging it into a public charging station or into a home charger. But to get the best deal for home charging, it's important to get the right EV electricity tariff, so you can spend less money charging and save more on your bill. How far you can travel on a full charge depends on the vehicle. Each model has a different range, battery size, and efficiency. The perfect electric car for you will be the one you can use for your normal journeys without having to stop and charge up halfway through. An electric vehicle's range is dependent on the battery size. The higher the EV battery, more power the further you travel. Here are examples of how far some electric cars' charge will go. Volkswagen e-Golf ranges up to 125 miles. Hyundai Kona Electric ranges up to 250 miles. And Jaguar I-Pace ranges up to 292 miles.
Another important aspect in EV is the science behind the battery. Because nowadays we are seeing a crucial part of the design is the thermal runaway or the thermal management, the battery explosion, how the battery is getting heated up, how can we do an effective cooling. The science behind battery is very important while understanding electric vehicle technology. And another critical component, as we mentioned, the battery. Can we run through some of the science behind the battery? Every EV has a battery pack made up of groups of lithium-ion batteries or cells that supply the power needed for everything from moving the car to running the air conditioning. It's usually located at the bottom of the vehicle between the wheels. Remember, the packing of battery, the positioning of the battery is very crucial in EV design because it affects the center of gravity, CG, it affects the cooling aspects and many such critical parameters. Battery sizes differ for each EV and many models also offer multiple size options. Bigger the battery, the more expensive the car. More than 50% of the car's costs belong to the battery. For example, large performance focused vehicles like the Rivian R1T pickup have double or more the battery capacity. Rivian offers 3 different battery sizes. The standard pack, which is 270 mile range with 105 kilowatt hour kWh. The large pack is 321 miles range with a capacity of 135 kWh. The max pack, the 410 miles range, has a capacity 180 kWh. There are now 2 main types of EVs on the market. In the past, it was mainly NCM, nickel, cobalt, manganese batteries. Now they were energy dense and offer high power and range. Recently, automakers have been quietly switching to a new type of battery called lithium iron phosphate in their base models. For example, Tesla, Ford, Rivian have adopted them because they cost less. No expensive cobalt and nickel, and achieve same EPA estimated range. EPA is abbreviation for Environmental Protection Agencies. So this is an image of a Rivian battery. Now comes to the powertrain, the motor design. An EV electric motor design doesn't have to pressurize and ignite gasoline like a conventional engine. Rather, it uses electromagnets inside the motor that are powered by the battery to generate rotational force. Inside the motor are two sets of magnets. Once it is attached to the shaft that spins the car wheels, and the other is inside the housing surrounding that shaft. Both sets of magnets are charged so that their polarity is the same and they repel one another. The force of the magnets pushing away from one another turns the shaft, spins the wheels, and moves the car forward. In order to maintain a constant state of repulsion between the magnets, their polarity has to constantly change as the shaft turns. Otherwise, they would eventually rotate back to the same point where they will attract instead of repel one another and lock themselves into place. So AC power does this automatically, constantly alternating between positive and negative. An EV inverter flips polarity quickly, around 60 times per second. That's a frequency. Okay, or the hertz, what we can say, to keep the rotational force going. A separate DC converter is used to direct power to other vehicle systems, which includes heating, the infotainment, music, and the lighting, so on and so forth. So that don't require an alternating current or an AC current. It can be directly operated from the DC. So these are a few images from electric motor of Tesla Model S and motor of Tesla Model S, again a more closer view. The Rivian dual motor on display at the factory. So let's listen the art of charging. So charging is categorized into three: level 1, level 2, and level 3. It's mainly based on its speed of charging. Level 1 charges are typical. They are slow charging, or the slowest one. 120 volt wall plugs and are most useful in private homes where you can use up the overnight charging. It's pretty slow. An 8-hour charge adds about 40 miles of range. A full charge can take 20 hours or more. The level 2 stations step up to 240 volts and output anywhere from 10 to 25 kilowatts for a full charge in about 8 hours. So that's a spec. This makes them the common solutions for overnight charging at home or locations like hotels. Tesla level 2 stations are known as destination chargers or versus superchargers. If you don't have the appropriate plug, a 240 volt outlet or home charging stations would need to be installed to recharge an EV at your house. Level 3 DC fast charging. These stations deliver the most power. They can charge an EV battery to around 80% in about 30 to 60 minutes depending on the station's charging speed, 50 to 350 kilowatt hour kWh. The maximum charging speed the vehicle can support and external factors such as weather, whether it's a very cold weather, which can take longer to charge, and so on and so forth. I mean, this is primarily to understand. One is the charging capacity and the technology, plus the ambient conditions also affect the speed of the charging. So this is a picture from EV charging station at motorway Xiamen in China. EV from an Indian station. Then Vietnam. VinFast is a prominent company from Vietnam. So these are a few images globally to see the growth of EV and which are demographically or population wise a larger chunk of EV vehicles are being pumped
or produced. How far can an EV get on charge? The most common EV concern is the range. For a single charge, how far the vehicle can be run. Will an EV will get the same mileage on a charge as a gas car or a fossil fuel car, or gets on a full tank? That's the typical question. The average EV range is 220 miles, according to data aggregated by EV database. But the upper and lower ends of the spectrum vary widely from 114 miles on to 2023. Mini Cooper EV to the Lucid Air's 500 plus mile range. Multiple variables can affect the range, both in the moment and over the lifetime of the vehicle. The size of an EV battery is one of the most consequential factors when it comes to the range. But whatever its capacity, an EV's range can be reduced by continuous highway driving, frequent quick accelerations, overuse of fast charging, extreme weather condition, and natural aging over time. Modern electric cars are becoming a more competitive options every year, causing more drivers to switch to EV technology. For example, in the US, EVs make up 7% of new car sales. A picture from Lucid Air Grand Touring. Okay, this has an estimated range of 516 miles range. This is from US. Now Lucid is starting a factory in Saudi Arabia as well. Tesla Model 3 charging at a Phoenix supercharger. Tesla is extending its manufacturing hub to Germany and to other global locations.
Traction battery pack. The function of the battery in an electric car is as an electrical energy storage system in the form of direct current electricity. If it gets a signal from the controller, the battery will transmit DC electrical energy to the inverter and then used to drive the motor. The type of battery used is a rechargeable battery, arranged in such a way that it is called traction battery pack. Power inverter. The inverter functions to change the direct current on the battery into an alternating current, and then this alternating current is used by an electric motor. In addition, the inverter on an electric car also has a function to change the AC current when regenerative braking to DC current and then used to recharge the battery. The type of inverter used in some electric car models is the bidirectional inverter category. Electric traction motor. The electric traction motors will work turning the transmission and wheels, using power from the traction battery pack. Some vehicles use motor generators that perform both the drive and regeneration functions. In general, the type of electric motor used is the brushless DC motor. A controller unit is an inverter and converter combination that recharges the battery pack of an electric vehicle during regenerative braking, which develops kinetic energy. The flow of energy from the battery is controlled using a controller unit in tandem with the converter and inverter combinations. The DC motor controller system is still used today on some electric vehicles to keep the cost down. However, with the advent of better and less expensive electronics, many of today's electric vehicles are using AC motor controller systems because of their improved motor efficiency and lighter weight. In an electric drive vehicle, the auxiliary battery provides electricity to power vehicle accessories. The charge port allows the vehicle to connect to an external power supply in order to charge the traction battery pack. This device converts higher voltage DC power from the traction battery pack to the lower voltage DC power needed to run vehicle accessories and recharge the auxiliary battery. Charger is a battery charging device. Chargers get electricity from outside sources, such as the utility grid or solar power plants. There are two types of electric car chargers. On-board charger. This charger is located and installed in the car. Off-board charger. This charger.
So with these details, the second episode of electric vehicle series is coming to an end. We'll stay connected. We'll continue on the third episode with more details. Till then, see you. Bye.